So for today, I would like to extend my invitation to Hassan and Saisa to please come on stage and pursue the further session.
Assalamu alaikum and welcome to all the participants. I would like to I would like to welcome you all on behalf of Lungs Energy Institute, which is operated in technical and in collaboration of the Institution of Mechanical Engineers of the United Kingdom. I have to stand here today, rather stand in for Dr. Mohammed Unib in his very large shoes. He has unfortunately been taken ill, so he could not be present in person and lead this session. Dr. Unib is the current chair for Middle East and Africa region for the Institution of Mechanical Engineers. I am currently supporting him in that endeavor. I was the previous chair for Middle East and Africa region for the institution. And currently I am the vice chair of the International Strategy Board of the Institution of Mechanical Engineers. So it's always delightful to be present in a university environment, work with an institution like Lahore University of Management Sciences. And it's a great initiative that's been taken to bring the industry and academia together and discuss how the technologies are evolving, new technologies are coming in, how to utilize them in the Pakistani context, and bring learning and cross-learning to from the industry to academia and from academia to the industry. So I'd like to introduce others also. There's Masroor Ehsan Sir. He's the MD of SB Electronics, and he is going to make his presentation on C&I microgrids. And I don't want to steal the show away from him and his presentation, but there are two things that we need to have a keen eye on when we are looking at microgrids. One is how it is not just about electrical energy distribution. We're talking about total energy, which includes thermal energy also, not just in the form of electrical energy. So we need to be aware that this is a theme that we will see again and again in this presentation. And the other one is how to optimize our load consumptions with the various sources of power and energy that we have. And through that efficiencies, we actually help the environment, help the cost base, and the efficiency of whatever operations we are doing. So these are the two themes that we need to clearly keep an eye on through the presentation. We have Dr. Fayaz Chaudhary, who's the head of the this team of Lungs Energy Institute, and he's advisor, senior advisor to it, and he's present, and he'll be present as the panelist also. We have Mr. Tanpat Kotak here, who is the ex-MD of National Power Parks company, and currently a very sought after and senior consultant in the market. Then we have Dr. Noman Zafar, who is the professor for electrical engineer of School of Sulaiman Dawood School of Engineering with us. So I think all the Lungs people know him, but He's a very accomplished electrical engineer and really delight to meet and know and learn from. And finally, we have Naveed Arshad Saab present online, who's the director of the Lungs Energy Institute. And under his overall uh, umbrella, we are actually doing some great things in the Lungs Energy Institute. So with this, I would like to bring Masroor Saab and invite him over to start his presentation.
Yeah, I can use the arrow keys. Yeah, convenient. ठीक है ना? Yeah, I don't need the point. Assalamu alaikum. First of all, my name is Masroor Khan, and I'm an electrical engineering engineer by qualification. And I've spent almost 40 years in this industry, especially distribution and transmission and control and instrumentation. I must thank the Institute of Mechanical Engineers, the Energy Institute at LUMS, uh, and LUMS itself, of course, to invite us on this very hot topic today, and very relevant to what Pakistan is going through. And everybody is feeling the cost of electricity, everybody is suffering from it, and the reliability, and of course, couple it with the internet outages and all. So this is one of the most important subjects today around the world, and as I said, very relevant to Pakistan. आज की डिस्कशन में हम जो थोड़ी सी इंट्रोडक्शन में दूंगा माइक्रोग्रिड्स पे and how they are being driven and why they are being driven, जिसके लिए the overall context of climate change is very important. My subject is not climate change, but microgrids in the world are being driven by climate change. उसके drivers renewables हैं, which are driven by climate change. उसके drivers resilience है, because climate events हो रहे हैं. So microgrids are needed sometimes for resilience also, where they can work on their own, disconnected to the main grid. And also in the context of Pakistan, where we stand in terms of energy consumption relative to the world. In the second part, which is the main part, I will discuss how we approach a microgrid and how we simulate it, how we optimize, and how we design. And then the third part, I will discuss the concept of digital twins a little bit, just for an introduction, that how it is relevant to microgrids and energy systems. And one topic I would just like to introduce today is long duration energy storage. And I feel very strongly that in Pakistan, this is for Pakistan is the most relevant technology and is not even mentioned anywhere. And the world has started to take benefit of LDES, which is long duration energy storage. You can also call it 24/7 solar, and we will just introduce some concepts of it. We, in our own organization, a small commercial organization, we've already set up a center for LDES applications research. Just to give an overall context, 51 billion tons of greenhouse gases are created every year. This is from Breakthrough Energy to Bill Gates' company. And typical uski जो breakup है कि manufacturing uses is 31%, electricity is 24, agriculture is 19% of the total, transportation is 16, buildings is 7. अब आपको बहुत सी hype सुनते हैं about electrification of the transport sector, but you will be surprised that all other sectors are also being electrified, including the home. Home electrification, people are moving away from gas and oil, and homes are being electrified also. It's not just EVs. In the context of Pakistan, of course, Pakistan uh, produces or contributes only less than 1%, less than even 0.9% of the total greenhouse emissions, greenhouse gas emissions, but is going to be majorly affected by it. But there is also another very important economic reason why Pakistan has to use microgrids, renewables into its energy mix. अब simple अगर climate data देखें तो possibly Pakistan is one of the lowest contributors. So उसकी कोई relevance नहीं बनती कि why Pakistan should invest in this. Let the big boys and the big industrial countries invest in the greenhouse, in the renewables. अगर आप पाकिस्तान का energy consumption देखें तो this data is from the World Energy Forum. You will look at Pakistan, though you will see that Pakistan is in the lowest ranks of per capita energy consumption, around 4,000 some hundred, a few hundred kilowatts hours per year per person. Whereas even India is about 30% higher. Bangladesh is 10% lower, Afghanistan is 30-40% lower than us. So this is where we are at. Look at Thailand, it's almost more than 20,000 kilowatt hours per person. So our systems have to be designed which cater to low consumptions, low load factors. Overall, the whole country's power load factor is less than 15% of the capacity. Despite this, Pakistan cannot ignore the renewable sector. Because even though Pakistan is not a contributor to the climate change, but for example, European Union ने carbon taxes लगा दी. वो कहते हैं carbon border adjustment mechanism एक create कर दिया. And this started with cement and steel and will be, और ये तकरीबन September 2023 में ये enact भी हो गया European Union में. So they are going to tax every good that is imported which has a carbon element into it. And वो अपने standards पे उसको implement कराएंगे, जो उनके commission standards हैं. So for our exports to remain competitive, we will have to invest into renewables. अब interesting बात ये आती है कि what is a microgrid and why a microgrid? So I'll just share with you. अभी हम पहले भी discussion थोड़ी सी कर रहे थे इस presentation से. The microgrids have existed for more than 100 years, for as long as the grid has existed. So why call it, what is the hype? Why call them microgrids now? Microgrids are basically a textbook definition. It's a set of connected loads and sources which are in clearly defined electrical boundaries and may or may not be connected to the national grid. It can be totally disconnected from the national grid. It can work with the national grid or in islanded mode. And microgrids have existed on islands for many, many decades. They have existed in cities, they have existed in industry. But in today's world, जहाँ पे renewables की वजह से local generation भी बहुत active हो गई है और उसका component increase हो रहा है due to wind, due to solar. उसकी वजह से microgrids have now being defined formally. And there is now a set method through which you can not only define microgrids, you can model them, you can optimize them, and a whole science has been created behind it. मैं थोड़ा सा अब आपको लेके जाऊंगा when we how we start developing a microgrid. We start with a load model, a load profile. अगर आप इस ग्राफ की देखें तो x axis is the time. For example, in this particular case, it is hourly data for 365 days throughout the year. So covers all seasons, covers day and night, weekdays, weekends. And the lower part is a zoomed in version of the same. And you can actually zoom into the hourly or half hourly interval also. The reason we have to do that, and we think that even in our company, even solar जो हम integrate करते हैं, तो we model it like this. For example, if you have a 50 kilowatt load, if it is for a school, it has a totally different profile because school ki working is very different from a home working, is very different from a restaurant's working, and is totally different from maybe an office work. School जो है उसमें summer holidays भी आ जाएंगे. So in summer, instead of increasing the load, it will decrease. School will mostly work during the day and will have winter vacations also. So anything you design for a school will be very, very different for the same load conditions that you will design for a commercial building or you will design for a residence. Residence में typical load profiles are that सुबह के वक्त consumption होती है और रात के वक्त consumption होती है. Typical residential communities have peak loads occurring between 7 and 12 midnight rather than, or even sometimes in certain cases, 5 p.m., depending on the season. And early in the morning, between 6 a.m. and 8 a.m. So load profiling is the first step in developing a microgrid and understanding the requirements for a microgrid. इस पे एक निशान सा आ रहा है, coming on the screen, need to remove that. Typically, once you've done a load profiling, you will also break it up. For example, this is an exercise we did for a proposed cement plant. And in this particular case, its 24-hour typical 365-day load curve was the way it is shown. And every color of the bar graph shows the particular process which which it represents. For example, packing line, crushing line, and different lines, how they operate and interact, and then you summarize and model its load curve accordingly. So the x-axis is 24 hours, and the y-axis is the power requirement. Right. इसको अगर आप देखें तो इस पर्टिकुलर माइक्रोग्रिड में टोटल जो एनुअल यूनिट्स रिक्वायर्ड है एनर्जी के दे आर 249 गीगावाट आवर्स पर ईयर. डेली 682 मेगावाट आवर्स, 682,000 किलोवाट आवर्स, और उसकी पीक वैल्यू किसी भी थ्रू आउट द ईयर वो 37 मेगावाट पे जाती है. और जो वर्किंग डेज है वो 330 डेज हैं एंड द स्टैंड बाय लोड इज 2 megawatts. So this is how you will first dimension the electrical energy system of a microgrid. Of course, the same concept you can apply to heat, steam, gas, water, all those requirements, all the other utilities, and you can all combine it into one model and aggregate. Just bear with us. एक मिनट लग रहा है. Some technical glitch. Okay. And thank you. Thank you very much. We're back. G. So once we've done and created this model for a microgrid for the load that we need to serve, we need to understand it better. So we create more analytics for it. So one of the very crucial graphs that we will create is a histogram. A histogram is on the x-axis, it shows the power requirement, and on the y-axis, it shows the frequency or percentage of the time, or actually in terms of hours, how many hours are required for that load. For example, in this particular case, if you look, so 800 kilowatts were the load is such that 800 kilowatts load was required only for less than 1% of the time. So this makes you decide a histogram whether you want to, how much you want to serve through base load or a high investment, high capital investment uh, source, how much you may be able to serve from a solar source or a wind source, etc. And how much maybe you need to serve from a standby source. So this histogram is one of the very important analytics that we do. Same way, this is a box chart. A box chart tells you what the median requirement is for a month, for a day, for a season, for a year. Okay, what the distribution of your load requirement is, minimum, maximum, and like you very well know the 2080 rule, where 80% of the load occurs in 20% of the time. So you can see from this box chart that what your median requirement is for every season, every month, and what your maximum minimum requirements are. And there are many other analytics that we have to do to analyze and understand the load requirement. This is another form, which is a heat map. A heat map tells us that throughout the year or over a 24-hour period, how my load is being used. Eventually, we want to get to this particular graph, which is a usage mix curve. And how we optimize it, we will show you in the next sections, the next slides. But for example, in this particular case, you look at the red curve, and red curve is the orange curve, which is the load, the yellow, which is coming from the grid, the blue is solar, and the red is excess solar. But whenever you have excess solar, you may be exporting it back to the grid, or you may be charging a battery and then using it later on. So this is the eventual result you want to achieve in a microgrid, that how your energy mix is being produced and available, and how you want to serve your load with it. So you can, for example, the excess solar, as I said, you can use it in the form of net metering if that is available, or store it in some kind of a storage like a battery and other storages that we will discuss in the coming slides. Once you start your design of a microgrid, it is very important that you also define what your primary and secondary objectives are. Okay, is the microgrid to provide service to the grid, like, for example, a grid support storage system, or a IPP, which is solar with battery backup, or some kind of long duration storage. You want to optimize distributed energy resources. For example, typically that we see in industry in Pakistani context is that our solar penetrations levels are between 10 to 15%. But you can go up to 30, 40%. But as soon as you start to go beyond 30%, then many other issues trigger, including oversizing of solar, excess solar, storing it, wasting it, or also the variations that are caused by renewables. You need to cater for that also as your penetration increases. And then, of course, you also want, maybe your objective could be some demand side management, that you want to use loads in a certain way, that you could use critical loads throughout the day. You could be using certain loads in times of day when only the electricity available is at lowest cost. Like, for example, water pumping, you may decide to only use it during the solar hours, if that is possible. Then again, critical resiliency is important. In certain cases, like military bases, like hospitals, there are certain parts of the overall load which are highly critical, and you want to have redundancy built there. You want to have availability of 100% guaranteed energy availability all the time. And in those issues, you have to define when you are developing your micro at the start. Once you've defined your objectives, there are various softwares available. For example, in our company, we use Homer, which is a US-based company. It's hybrid optimization of multi-energy resources. And in that, you provide all the project inputs, economics, interest rate, debt, equity ratio, discount rates, and you provide site-specific renewable information and other system components, including sometimes, if required, grid tariffs and all can be built into it also. So that grid tariffs, if there is a penalty for high demand, or there is a peak off peak charge differential, so you can use that in optimizing your costs. Once you put all your parameters, then that is what we call the simulation. Then simulation is run, and the system runs hundreds and actually thousands of models and optimizes it according to the dimensions and your objectives. Whether you want to optimize cost, you want to optimize resiliency, or you want to optimize renewables because there's a requirement for a certain minimum percentage of renewables in your system due to carbon emissions or whatever the case may be. Then you get output of economics and engineering together. System sizing, performance details, financials, and various other reports you can get, like how you are serving the load, whether you've allowed outages or not, etc. Then finally, you see that green circle. That is the sensitivity analysis. Then you can make sensitivity changes. You can say, what if my cost of debt is not 15%, it's 20%. So what will happen? What if I increase the size of renewables? What if I add some more battery energy storage to it, etc.? So you can do many sensitivity analysis and come up with a model. Remember that a model only is possible for a model, it's only possible to represent one instant or one uh, cross section of the whole real life scenario. So you have to make many cuts and look at the real life scenario from all angles to be able to understand your own requirements. The typical feasibility assessment details are like you see on the slide: inflation rate, debt percent, equity. For example, in this case, it's 80-20. Term of debt, whether it's 10 years or not. Project life is 25 years. Discount rate is 8.8 years. Minimum genset loading, if you want to set it, you have gensets. So typically it's 30, 35, 40%, depending on your particular gensets. Maximum genset loading, it could be 80, 90, or even 100. And you can even limit that. At 100, you will only go for a few hours. Then grid cost analysis, you can provide that as an input to see how you are comparing with the grid. Of course, these are all old numbers from last year. Today's Pakistan grid is almost twice this cost. So fuel price adjustment, standard tariff, quarterly adjustment, and for example, for a typical industry, last year it was 27 rupees. Then you create a comparison between your base system and your proposed system. If you have a current running system, you call it base, or if you are proposing a base system, that becomes your reference system, and then you keep on doing many sensitivities to create your proposed system basis. For example, in this particular case, we calculated the capex was 5.48 billion in the base case, but when we added renewables, it became 8.58 billion. OPEX in the base system was 7.23 billion per year. That is the operating cost. And in the proposed case, it became 6.45. The levelized cost of energy was 21 rupees, 32 paisa. And in case of the proposed system was 19.38. CO2 emitted and HFO consumption figures. So the LCOE of PV in this particular case was 3.56. And please remember that a solar system, a solar PV system, for example, can have totally different costs depending on how you finance it. The same system, if financed from equity, has a different cost. If financed from commercial loan, will have another type of cost, LCOE. If you finance it through green capital, then the cost is totally different. And it can vary between 4 or 5 rupees to 10 rupees, 11 rupees, depending on how you finance it. So you come up with the proposed system financials. You say simple payback is 3.94 years, return on investment is 21%, interest rate is 25%, internal rate of return is 25%, and discounted payback is 3.84. So all these financial numbers are also churned out by the model. And you can do as many sensitivity analysis as you desire. And these are from last year. At current prices of the grid, all these numbers have doubled. And the payback period has halved. Initially, when the point we were discussing earlier was, initially when we design a system, microgrid, we take now, in the world now, they take a different approach. Traditionally, systems were designed for transients first, and then the steady state energy cost or system cost was a result. Now they say, no, you reverse it. Any energy system, please remember, has two main parts. One is the steady state part and the other is the transient part. The transient part is anything that happens under 1 minute, under 1 second, and sometimes even sub-cycle, which is 20 milliseconds. Those are all transients. So we designed the system initially, that is what we call initially, it's a 30% system design. In the initial setup, we only design the steady state energy system. और उसके अंदर we try to define what the basic size of assets is, how you interconnect the microgrid to the main grid. It could be something as simple as just a net metering connection, or could be a more complex microgrid controller, central controller type point of common coupling design, as you will see. And once we have this basic sizing and all, and we have satisfied ourselves with its economic returns, then we move ahead. So cost estimation and financial planning, as I said earlier and explained, we complete that. Once you are satisfied with the first part of your steady state energy system, then of course you need to cater for the transient also, because without that no system can run. But you don't want to size in the first step according to transient requirements. You need to first optimize according to your energy requirements in the steady state, and ensure that if, for example, cost is your objective, so you have the least cost of system in terms of capex as well as opex, and the best possible return. Now this system then you design and simulate in a software like ETAP or any other like Siemens software, and you create load flow, power flow studies, stability studies, short circuit studies, and do the whole power simulation suite you run on it. And you make sure that the system will cater to all the transient requirements and has reasonable and enough protection for short circuit, for outages, for voltage sags, wells, etc. The basic challenges that you have to face are, of course, system design, protection and automation, integration and operation. Black start is a very important aspect of microgrids. Typically, for example, one of the microgrids that we work in Lahore, we work with them, is Lake City. And if there is an outage, it's an islanded microgrid. If there's an outage, so starting back the system and putting it back on takes more than 30 to 45 minutes because of the inrush current issues and all. And resiliency, that is very important also. That how resilient is your microgrid to outside events, grid events, like you were asking, sir, and also internal faults, etc., that may be coming from the consumer. Typically, you have to decide between when you've added distributed energy resources, that whether you want to use them in a grid forming mode or grid following mode, whether you want to use it on group-based operation basis, or transients during and in between transition. This basically means that, as I will show you in the coming slides, that the basic characteristics of renewable sources is extremely different from rotating machines. Renewables don't have inertia. So instantaneous values or instantaneous surges cannot be catered by them. So it is very important to understand when you especially have a high energy mix of renewables, that how you will operate them. You need to understand your asset capabilities, your load side, whether you need sub-cycle load shedding. You need to decide how you will restore. You need to decide how you will control. And on the generator side, whether you have long-lasting fuel sources or not, whether they are reliable, or there can be fuel outages. For example, it takes for a major storm in the US, I'm talking about US because that is where the data is available. major outage in the US, the electricity can be recovered in about a week. But if there is a major storm, typically diesel transport lines, gas lines will take 2 to 4 weeks to recover. So you have to make sure that if you're using gas, diesel, or others and you need resilience, then how will you manage it during climate events? Asset capabilities of renewables, you need to understand real power fluctuations. For example, solar is not constant throughout the day, it is continuously varying. And again, if you are connected to the grid and you have only 10% solar penetration, it doesn't matter. But as soon as you go to 40, 50, 60% solar penetration and you have two island at the same time, suddenly it becomes a totally different thing. And again, if you want to add reactive power or not, these are the kind of decisions you need to make for renewables. You can run, as everybody knows, you can run renewable in power mode or reactive mode as you wish. But then there are competing compromises based on operating costs and the amount of energy you will produce. Similarly, for batteries, if you're adding batteries, you need to understand why you are adding batteries and how you will run the battery in case of an outage, etc. Typical things that in a microgrid, especially connected to the main grid, you need to take care of are power quality issues also. For example, voltage sags, swells and interruptions, short interruptions. They are very crucial. And you need to understand what the grid is providing. And for that, you can only make measurements. You can't see them, and there is no document, especially in Pakistan, where you can get detailed data, so you have to create your own experience. This is one of the main reasons why when you are adding renewable, you have to make sure that transients are also taken care of, and especially in high penetration renewables systems. On the left side, the curve shows you that electric power requirement can suddenly change. They can change within 1 or 2 cycles, which means 1 or 2, 20 or 40 milliseconds. But if you have captive power plants and rotating machines, they cannot respond faster than 20 seconds. So you can have an outage if you're not connected to the grid. So how will you cater to that? Then when you add renewables, this problem even becomes bigger. Because if you look at the right side of this curve, you will see that for rotating machines, the dotted line on the left shows the short-term capacity limit, which is the yellow line, which is compared to the yellow line on the left curve, is multiple times higher. So for short instances of sub-cycle, 20-second, millisecond events, the rotating machines can serve a much larger capacity because they have inherent inertia. And we consider grid to have infinite capacity, so it can serve instantaneously. But renewables don't have that capacity. In new inverters, etc., people are building capacitors or coupling them with supercapacitors to cover this shortfall. But you need to understand that your renewable will not be able to serve your transient needs. And as you increase the renewable percentage, it will can cause again system instability. This is a typical curve for smoothing renewables. For example, the blue line is the solar production during the day. It is varying, so you can add some kind of a supercapacitor or a high-speed lithium-ion battery bank, which can smoothen out the solar output. So for literally every cycle, the supercapacitor is charging or discharging, and ensuring that the solar output remains constant. Then you need to develop dispatch strategies that if you need to do load shedding, then whether you will do equal percentage load shedding. For example, the microgrid that we referred to in the Hot Lake City, we are actually doing this for them right now. But in case you need to sometimes do that, what will be your dispatch strategy? And if you have multiple feeders, how will you shed load instead of damaging the system? And base operation priority, that then economic factors and operation rules. You need to define all these things. The economic factors you need to consider are fuel costs, efficiency curves, energy pricing, external and internal, and primary. What is the cost of from the grid? What is the cost of primary fuels and energies? And what is your own forecast? So load forecasting has become a huge field, as you have seen in the Pakistan power system, that if you've over planned load growth, you've run into all these inefficiencies which are causing very, very high costs. So in a microgrid, weather forecasting is also very important. So for any large renewable system, we are typically installing weather stations, which are getting weather data, interval data, and then we are comparing it with the actual required load requirement. Transition cost, and you may have requirements for internet connection agreements, typically whether it is an IPP or a renewable source or a microgrid. There is a interconnection requirement, for example, with ESCO, that what your interconnection agreement is, how much you can maximum export, whether you can export in certain timings or not. Then you need to decide its operating routes, that if you have a battery, how will the battery be utilized? Whether you want to charge battery for only renewables, maybe you want to charge, for example, we did a simulation for a farmhouse, and the owner did not want to charge the batteries during peak hours. So these are the kind of decisions that you need to make when you are then defining the operating routes. And then you typically program these in the central microgrid controller, that how you want to run the microgrid. Whether you want to smooth the fluctuations of renewables, and if you want to prepare for weather resiliency, for example, in this particular case of the farmhouse that I was mentioning, it was not a weather event, but like weather or the result of bad weather, the farmhouse is on a rural feeder, so there can be outages of sometimes even 2 days. Okay, so you have to treat it as if it is a weather event, and then cater for it. Or even in sometimes you can work with emergency loads. That if there is such an event, then you can decide that you will only run these more critical loads for 1 or 2 days according to your needs and the needs of the customer. Peer-to-peer पाकिस्तान में अभी relevant नहीं है, but future में ये भी चीजें will come in, where you will be able to exchange, possibly exchange peer-to-peer energy also. The questions that you asked, that these are typically the commissioning requirements of the system. Pakistan NEPRA ने भी similar guidelines adopt की हैं, which are in line with IEEE 1547 for point of common coupling, and IEEE 2030.7 for point of interchange for various kinds of distributed energy resources. And of course, IEEE has also defined a protocol on how you test all this. You can also simulate this and test it in hardware in a loop, which we have not done in Pakistan, and there is no facility right now available to do that. And also, such complex microgrid control is still not implemented in most places. Once you have a microgrid, you also need to collect all its data. And typically, this is like a dashboard that we create. We create a landing page for every customer. If it's a complex microgrid like Lake City, or even for Imtiaz stores, for example, we monitor their energy system throughout the country. Or even telcos like Jazz, and over here you can see total energy consumption and various other attributes you create on the landing page, and you can drill down, you can click on every button and go into and see your live data. This is another form of analysis where you create a calendar chart and you try to understand how your microgrid is actually consuming. So this calendar chart is typically represents every week, 7 days of every month, every week, and then 4 or 5 weeks of the 4 and 4.5 weeks of the month. And this is organized according to the calendar day, Monday to Sunday. And from here you can visually analyze, as well as we also have AI tools which analyze all these. Typical solar daily generation charts in terms of what the solar has produced, what you have imported, what you have exported, and you can do that for 24/7 again, for every hour. Interval data, what we call, or time series data, is the building block of all microgrids for production as well as for loads, for sources and consumption both. And when you have this data, you have completely digitized your microgrid. And you can then do any kind of analysis, application development that you want, tariff design. From here, we come to what is a very, very important subject and is being used everywhere in the world now, what is called the digital twin. So how you create a digital twin is, again, you have all the data as well as you model all your machines. For example, if you have a DG set, a certain model, so you will have its software model with it also. How it performs in terms of, for example, how its efficiency output is according to its loading. What is its efficiency output according to elevation? What is the efficiency output according to temperature? So all that model is built in. So every machine, grid, or renewable source that you have is modeled into a digital twin, and then it is connected to your load consumption profile and your source consumption profile. So that creates a complete digital twin. The digital twin is extremely important for future planning, for strategic analysis, for ensuring that your needs for the years to come will also be catered to in the most optimized and efficient way. The benefits of the digital twin are real-time monitoring and control of the energy system, which was traditionally called SCADA. SCADA is an old word. It is no longer relevant because now today's new world is what we call AI-enabled Internet of Things. So every system has to converge to that. Then because of that, you can create data-driven insights. You can do simple process of automation of your reports and create algorithms and simulate them. And you can also create insights from larger data that the system generates on its own. For example, we've developed an application for telecoms where we are doing intelligent diesel pouring. So the system will predict what outage will be on a tower site based on its history, based on future weather and all. And based on that, diesel procurement plan is created. And then we monitor it every day and update it every day. So it is creates a diesel procurement plan for the next month, and then it updates of what is happening every day. So you ensure that your diesel procurement is efficient. You ensure that your diesel consumption is as per your plan, or if it's deviating, then it's according to the efficiency of the machine you have. And you can identify pilferage or inefficient usage, or even sometimes inadvertent or idling usage, that the generator is on, but there is no need, grid is also available. A lot of times this is also happening. You can also do enhanced predictive maintenance. So you can put in the energy into the preventive maintenance equation also. Typically, preventive maintenance was done when there is a noise or a problem with the machine, not when its energy consumption went 10% more than designed. So now you can do predictive maintenance also of your machines, of your systems, of your sources, as well as your load. And of course, you can create what we call energy reporting systems like energy performance indicators. For, for example, for a bottling plant, we created that kilowatt hours per crate of production, okay, per case of production. And they monitor that. And they see, and sometimes you can see that shift A use the least amount of energy and shift C use the highest amount of energy. And the system can identify it. And then, of course, like I said, strategic planning. You can use it for strategic planning. आज की आज की दुनिया में जिस तरह आपने देखा हर चीज is becoming digital. So what we call microgrids are also possible because you can digitize all this data. Once you digitize it, you can process it. You can create applications from it. And our core model for handling all this data of devices is that we have inputs, AC meters, DC meters, whether they're electric or they are even heat meters, they all create interval data. And the standard protocols, it can be any external device. It can be a solar inverter, and we are connected to it, and it comes into our cloud server. The communications can be 4G, 5G, LAN, Wi-Fi. If you just want reporting, then typically a standard 3G, 4G network or a LAN network, Wi-Fi is okay. But as soon as you want control in it also, then you will typically, for mission critical process plants, you can go for proprietary 5G applications, which are localized within your plant. For example, there has been a big project in Saudi Aramco where one of their main refineries uh, is now using proprietary 5G application because it has extremely low latency and the response times are in less than around 1 millisecond. So those are applications where you need control also. But for typical energy management application, a 3G, 4G network, LAN Wi-Fi is good enough. Once we have it in the cloud server, the data, then we have a data extraction, transformation, ETL is called, and loading module. And all that data is then parsed, cleaned, validated. And in sometimes when you have data loss or data corruption, then you sometimes have to estimate also because you may have a billing application from this data and you have a data loss. So how do you estimate it? Typically what we call V rules are applied: validation, editing, and estimation. And then typically once you have the ETL set up and you've loaded all the data into your database, you will use some kind of a BI tool. We use Qlik for reporting and creating dashboards. Or you can connect it to an ERP system you can get data from the ERP system, connect it here, and all that. So you can do data export to any third-party system, as well as import. Typical energy system outputs are kilowatt hour consumption, power reporting and alarms, demands management, voltage current, power quality reporting and alarms, outage event logs, and any other special reports like load outages, load sheddings, diesel systems, operation and efficiency. You can, as I said, communication systems typically are RS-485, LAN, PLC, RF, ZigBee, narrowband IoT, which is now finally PTA is also issuing licenses in Pakistan for narrowband, like LoRa network. And then between devices and collectors, typically GPRS, 4G, Wi-Fi, and LAN. Finally, I am coming to the last part of this presentation. LDES is long duration energy storage, is a new and upcoming technologies in the world. It is for long duration storage of electric energy in the form of heat or in the form of power. So it has power to power application, it has power to heat applications, etc. The oldest LDES technology was pumped hydro, where during the day or during the time when you have cheap energy or excess energy in the grid, you could pump water back into the reservoir upstream. And then when you need it, you flow it downstream and create hydropower. So that was the most traditional. There are maybe, if I'm right, more than 400 projects around the world. I don't think there's one in Pakistan yet, but we are working on one possible project like that. So pumped hydro was the most traditional and very, very successful, reliable. But like every other hydro project, this also requires a lot of capital, a lot of land, a lot of access to a lot of water. So you don't have the freedom to install it anywhere. LDES technologies are other than lithium ion. Lithium ion batteries or similar batteries, nickel or sometimes even lead acid or whatever multiple forms you have, they are not good for long durations. When I say long duration, you are typically talking about 8 hours, 12 hours, or even sometimes weeks. This is how they define the long duration energy storage. इसके basic 4 forms हैं: electrochemical, which are some kind of a battery; thermal, which is our heat solutions; chemical, which is like green hydrogen, methane, etc., and mechanical, like compressed energy storage, pumped hydro, etc. A lot of them are in the experimental stage, and a lot of venture capital is going into the world, literally billions and billions of dollars in developing this. Because LDES technologies will make renewables available 24/7. Typically in the US now, the new RFPs for renewables ask for 24/7 renewable availability. And that is also being triggered by that two very classical events that have happened. One is that the Irish grid was, for the first time, any grid in the world, national grid, ran for 4 hours purely on renewables. That was a milestone. And second event is that in Texas especially, now there is negative pricing of renewables also in terms of excess times. Actually, the IPP is paying the grid to use its solar because of other contractual requirements. They don't want to disconnect. But LDES can solve all that problem. So typically you're looking at these technologies, and what it does is the result of the LDES is, sorry, we again have a glitch. So typically the result of LDES is that if you have a solar typical production curve during 24 hours of the day, you can convert it into heat or steam or even power to power applications. Okay? So typical, the most cost effective is power to steam, and then there is steam back to power or direct power to power also. But the most developed one right now in the world is where you can convert renewables to some kind of heat. And then heat can be converted. You can create steam with it or hot air as you need it. So you can have an intermittent solar requirement, and then you can store it and get a flat, continuous heat energy from it, like shown over here in the blue line. The blue line is the same amount of energy that the solar produced, but is spread 24 hours of the day. This is going to be a revolutionary technology in the world, and especially for countries like Pakistan, I believe, where you will be able to get rid of and actually eliminate the use of fossil power and use renewables 100% of the time. A typical heat battery, this is the company Rondo Energy, which is one of the leading heat battery companies. The concept is that you have intermittent renewables and even grid to support it sometimes. And you can heat some kind of a ceramic material. These are all simple but specialized materials which can store energy for long durations and can also discharge. So they are not just insulation bricks. You also need it to discharge very well. So they have to be conductive, as well as they have to be to have a large capacity to absorb also. And then this heat, if you see in the fourth part, is used to create hot air or steam, put a steam generator, and you can have an output as when I have water in and steam as output. And these are no longer experimental. These have all become commercial today in the world, especially the heat batteries. With that, I end my presentation. Thank you very much. Appreciate it. I hope you enjoyed it, and I was able to introduce some new concepts as well as explain microgrids. Uh, One last point that I think LDES will totally much more than even the hype is about electric vehicles. But I think this technology is the dark horse and will totally change the uh, will totally change the landscape of the grid as we know it today, and will give a lot more control to the consumers rather than their dependency on central planning and on the inefficiencies of central planning and the high cost that we all have to bear because of that in country like Pakistan, and especially Pakistan as we are facing it today. Thank you very much. Thank you.
So I would like to thank Mr. Saab for very enlightening presentation. And would now like to bring the panel to the fore. I would like to invite physically present here, Ankur Kutak Sir. I would like to request him to come to the front to the panel chair. And Dr. Moman Zafar Sir, if you could take your seat. And I just want to need a confirmation if Fayaz Saab is present in the meeting as online, so that he can participate in the panel discussion. Right up there. Okay. So the three of us will manage. I moderate from there. So I'd also like to invite Masood Khan sir to come to the fore and take a chair on the panel. So one of the takeaways that I have from this presentation is that really from the presentation what I've understood is that this microgrid is really a method, and it's a know-how which helps us analyze a particular site or particular location and come and utilize the knowledge we gain from there to bring about greater efficiency in our utilization of energy and in terms of cost as well as the environmental impact. The other one is what I found interesting was that when you mentioned providing services to, say, for example, Imtiaz stores and their network, or the telecom companies for their hundreds of towers across the country and bringing their data, you're actually, it's a different way to look at a microgrid. So you have these nano grids spread across the geography of a country or a city or province. And you're bringing the data and you're actually looking at it in one go as one collection of nanogrids or whatever you want to call them. So that's a very interesting application of the concept. And in that vein, when we look at our homes, we are actually all nanogrids in our own right, because we are actually a very interesting term that is used by Mr. Saab as prosumer. So you are actually producer of energy if you are producing from solar. You are actually supplying to the grid also, and you're buying from the grid also. So these are two very interesting insights that I have. Now, one of the experience where I actually utilized the method of microgrid to help one of my clients. Well, I'll just share the experience and the outcome before I put a question myself to Masood Saab to explain. We had a client who actually utilizing conventional way of working on designing their sourcing of power for a particular site. And they said, okay, for our site, 6,000 100 acres with 12,000 expandable to 12,000 acre site. A manufacturing site with multiple use commercial and residential also. They estimated that they needed a 30 megawatt coal-fired power plant along with a 14 megawatt solar, and the rest was from grid, etc. And grid connection they estimated to be 50 megawatt. And when we applied the method, the microgrid method, to analyze and did the simulation like this one, we actually found out that they would have otherwise concentrated on bringing on better and better technology for coal-fired power plant. We want this much efficiencies, and then when you're talking about improvement in efficiencies, you're talking about decimal points in green enhancement, one technology over another, one supplier over another. A lot of effort was going to be spent in, and a lot of money also, because when manufacturers are coming to you trying to sell their know-how technology for a power plant, they're actually charging premium. So for few points of efficiency, you may have to pay millions of dollars extra, and that is the line of negotiation, etc. would have taken. When we looked at the analysis, and we found out that they would have actually, if it was based on cost of energy delivered, they would have needed to run the coal-fired power plant few hours every day, or almost every day. So in order to do that, coal-fired power plants cannot be run like that. You can't switch them on and switch them off at will, right? So they would have had to, once, if they had opted for that decision, they would have actually tried to create value by negotiating on the X00% extra percent point of efficiencies, paid extra for that. While they would have, in practice, they would have had to run the power plant all along 365 days a year, because or 350 days a year, and operated it at a high cost. So sometimes you're looking in the wrong place. And the method of microgrid actually allows you to do that. And we were able to then help them opt for something that was considered to be counterintuitive. We asked them, well, if to utilize that few hours of you need thermal energy, thermal power. So you really need to go back to furnace oil and put up a few diesel generator sets in that context, right? And then you start them and stop them as you need. And that was the most cost efficient and investment efficient option. And then we were also able to then enhance the penetration of solar from what they had conceived from 14 to 32 megawatts. So this is one example where I personally used the methodology, and we helped the customer immensely by helping them take the right technical decisions by looking at the techno-commercial side first. And if you don't do this, I mean, you may be losing opportunities in two ways. Either you make a wrong investment, or you prematurely discard a very, very good option because you've not actually looked at it the right way with the data and analytics behind it. So my question to Masroor Sahib is that how does he foresee the use of this method for strategic energy planning in the context by anyone, for example, an industry or a housing estate or the state also, government of Pakistan also, or anybody, to utilize this methodology to have a strategic plan in place, looking at 5 years, 10 years, 15 years, 25 years, and examining and taking into account the vagaries of the international energy market as well as the policy vagaries in Pakistan.
Do we turn this on, or is this going to be sufficient?
Thank you, Austin. सबसे पहले ना let me थोड़ा सा backtrack a little bit on a higher level. कि देखें, energy is crucial to human development. के कहते हैं कि humanity developed on free energy. कि लकड़ी तोड़ो जंगल से और जला लो, और वो energy produce हुई and you keep on developing. Energy is so crucial. I'm not a political person, but what we see reality in the world today, energy is so crucial कि जिन मुल्कों को अपनी energy security का एहसास है और cost को खास तौर पे, वो unfortunately, but वो अपने मकसद के लिए दूसरे मुल्क तबाह कर देते और फौजें रखी उन्होंने इस काम के लिए. So this is how crucial energy is. So this is another opportunity that we countries like us are getting, if we are hopefully not able to miss this bandwagon, is that now you can produce energy through technology without the use of primary fuels like solar, like wind. And if you are able to store it, you have another opportunity coming at you, knocking at your doors, where you can use these technologies of solar, wind, couple them with LDES, and you have a totally different paradigm of energy, cost of energy, availability, reliability, no dependence on foreign exchange, no dependence on, or very little dependence on one-time limited dependence on technology. And then you can develop these important technologies and actually start producing them yourselves. You are no longer dependent on the deserts of Arabia or the fields of or the coal mines of Indonesia to actually be have access to cheap and available energy. Please understand that that low cost energy availability is now a fundamental right. There is no life without energy. There's never been. Life has developed of energy. And this again, we have a new opportunity. So we should be able to use it as best as possible. The more we model it, the more we create and use know-how and new digital techniques which have proliferated all across the globe. So it's not just IT, it is all what is enabled by IT. Like even energy is now enabled by IT. Because when you digitize energy, it's difficult to comprehend, but when you digitize energy, you are able to transact it, trade it, peer-to-peer, do peer-to-peer trading of energy. If you had not digitized it, you have nothing to sell. Unless you can create, transfer, measure, transact, and then couple it with some kind of a financial transaction, your whole cycle can never be complete. So like the example you said, that of a coal-fired boiler. Now, if you made a strategically wrong decision of installing a coal-fired power plant, no matter how much more efficient it is than the previous one, or no matter how low cost it is a wrong investment. It will never pay you back. It will always cause a loss to you. So that is how important the strategic decision is, because it sets your direction for next 20 years, whether it is a microgrid for an industry or a housing society, or it is even eventually the national grid. like you've seen, we are now set into a trap where for 20 years we can do nothing except for just not only cry, but actually throttle our growth as a nation. This is how crucial it is. I hope that answers your question.
Okay, thank you very much. I'd now like to go to Dhanpal Kotak Saab to ask him what his takeaways are and what he thinks about microgrid.
Hello.
Hello. My question from Masuri Khan is this microgrid, he well explained from the emission to LDs. But my question is, this is okay, beneficial for the any industry. That's good. And the individual consumer has own solar system in some houses. But overall, this microgrid, how become beneficial to the common consumer? And also, the second part of question is, how it's more beneficial to have the national grid?
The first part, thank you very much, Mr. Khan, for a very, very actually important question that you raised. Number one, जो microgrids हैं, once they are all going to be connected to the grid, and sometimes they can be grid owned also. जो consumer है, they will eventually benefit through CTBCM. How you may have heard कि पाकिस्तान में भी अब ये जो electricity market है, इसको open कर रहे हैं, that will create peer-to-peer markets eventually to the consumer level. But B2B, business to business, जिसको के हमारे में wheeling भी कहते थे या कुछ, they will get enabled. जो grid है, that is the nerve system. So you need that grid, and we need it to be intelligent. We need it to be digital. जो traditional grid थी, it was a dumb grid. But जैसे ही आप उसके ऊपर information technology की layer डालते हैं, it becomes a smart grid. And the difference is that every stage you are measuring it. So it will become crucial how the CTBCM is operated. Whether eventually there is going to be a meter services company which is going to be independent and will create all the digital data from which you can do transactions, or no. Whether we will go in a direction where we will keep it nationalized and we will keep it in the holds of NTPC, and the meter services will never become independent. If those services don't become independent, then information will never be shared. If it is not shared, then it is not transactable. So it is our choice. I hold this very strongly. कि हमारी आपको पता है हमारी आदत है, we have many conspiracy theories on everything. But अमेरिका ने सानू दस रहा है करना या नहीं करना है, ऐसी खुद decide करना. If we decide and take this decision that we are going to create CTBCM in a free market, yes, then we need independent data operators who validate that data also, and exchanges of all this data between IPPs to consumers. And then you can have these microgrids contributing as prosumers, and you can reduce cost for the average consumer also. So this is how it can fold out. This is an optimistic way of looking at it. Generally, I'm an optimist, so I will look and make effort to create such a scenario where you can eventually have trading between microgrids and individual consumers eventually also. But when you are trading between microgrids, then you will be able to reduce the system costs, and you will be able to serve their needs better also through indigenous energy. So does that answer your question?
Yeah.
Thank you.
And may I request Dr. Numan Zafar Saab to forward his views on microgrid.
Thank you so very much. Again, a very enlightening talk on microgrids. I would like to sort of add a few perspectives to the overall concept of microgrids. I mean, at Lungs we work on microgrids. Our primary target, I mean, is on a segment of society that's generally neglected, and these are the people who are actually not connected to the grid, or grid does not is not there in a very stable manner. So they're bad grid areas, and the number of people in Pakistan, which is the fifth largest population, is staggering. It's between 50 million to 80 million people. And to put this number in perspective, I mean, sometimes we lose context in a country where we have 230 million population. Australia is a country and a continent that's 10 times larger in area than Pakistan, but the total population is around 26 million. So we're talking about a segment of society that's 2 to 3 times the size of entire population of Australia that do not have stable access to electricity. And that basically means that that's a portion of our society that cannot contribute productively in the growth of economy within the country itself. So when we talk about energy access, we're not talking about the energy which is for the primary needs of this segment of society, but we call it energy provisioning beyond subsistence. So it is providing them with energy which can allow them to run productive loads. And that's the only sure and sustainable manner of bringing them into the fold of energy itself. If they can, because they are a segment of society that's generally below the poverty line, so they themselves may not be able to, in the current situation, even afford access to electricity. And the government for sure does not have the fiscal space to take the grid to these people. If we can provide in a sustainable manner access to energy where they can enhance their productivity, create enough fiscal space that they can then pay for it, that would be the only way where we can grow and include them into the folds of economy in a sustainable manner. When we talk about the concept of microgrids in general, about this segment of society and also the segment of society that's connected to an evolving grid, which is becoming more intelligent, which is becoming more enabled, and also increasing in complexity when we talk about the existing grid infrastructure. I would generalize the concept of microgrids to consist of 5 different areas that have to be addressed. We need to understand the generation aspects, and these include newer renewable energy-based generation sources with all their eccentricities, and the traditional sources of power generation. And these are typically those sources where the source is in our control, but the behavior, the characteristics are different. But we need to understand the generation aspects. We then need to understand the load aspects, because load is typically what we eventually serve. That's the purpose of everything, is to drive and serve the load. So we need to understand the behavior and characteristics of different types of loads. The third increasingly important area is the storage area that Masroor Saab touched upon. And again, it's what typically did not exist for over a century and maybe 20, 25 years, where the grid did not have any form of storage integrated into the overall energy and power flows. and the load side and generation had to be matched in real time. And that was only possible because the source was in our control. But if both ends are now variable, the load is variable and the source is also variable, then the stabilizing factor comes from the storage itself. And again, storage is an entire area, and we need to understand the various options available for storage and what the characteristics of each type of those storage solutions entails. The fourth area, which is again an independent area, is the concept of scalability, where whatever we design now, the requirements over time, hopefully in a growing economy, would increase. So we're not talking about a snapshot of design, but a design which is evolving and in general evolving in one particular direction, whereas the fatigue of the system, the aging of the system is driving it in the completely opposite direction. So over time, our generation from a particularly typical installation is going to decrease over time. The storage capacity is going to decrease over time. The utilization or the requirement from the load side is going to increase over time. So the architecture needs to be able to evolve so that the newer aspects can be integrated without affecting the existing infrastructure. And the fifth is the communication and control, which historically never existed, but is now becoming increasingly important and increasingly prevalent in the concept of smart grids, and in this case, our case, microgrids. So again, it's these 5 areas that have to be understood and managed overall for the concept of microgrids to evolve. And then there are these approaches that Masroor Saab so eloquently presented in terms of how to understand what the requirements are and how to go about a systematic approach in designing and creating a solution that can decrease the overall complexity of the evolving grid by these microgrids, which become aggregators of the concepts within their own domain and provide in many ways a singular interconnect to the larger grid. So it increases the overall capability of the total grid, but at the same time decreases in many ways the complexity of the overall grid. So this, I think, is where the drivers are and where the direction for the microgrids is going to evolve and why it's going to evolve in that direction. So it would be the existing grid and the increasing complexity because of various reasons, including the different new types of loads, and also looking at those areas that are not being serviced by the existing grid, and we still need to provide a self-sustainable solution for those communities that can work in a disconnected islanded mode and can also allow grid interconnection whenever that becomes viable. So again, yes.
Thank you. Thank you very much, Dr. We have a few minutes to debate on this. 1 minute to Dhanpal Saab. Would you like to comment on what could be the challenges and what the problems are in developing such microgrids for rural communities? And then I'll go for 1 minute to Masroor Saab, and before going to Q&A session.
Yes, this is correct. There are a lot of challenges. First thing is the awareness. We have to give the awareness to the different industry and as well as to the individuals that how this microgrid will be beneficial. And secondly, especially the as the microgrid definition is certain boundary should be there. So such societies, these housing societies, which are, to say, independent as well as they are taking the load from the grid. So this microgrid can be beneficial for those also. But the still need to give the awareness to the community, awareness to the individuals, awareness to the industry, so that they can use this system. Thank you very much.
Dr. Bari rightly pointed out, and Professor Bhabdi, I totally agree, Kiwi, but that's another subject because it's related to social development, and of course it's aligned with social development goals also, and all, and right to life, etc. But those are another kind of microgrids, which have been, I think, now NEPRA has also provided some guidelines for it and is licensing such microgrids up to 5 megawatt. And I think that's the right direction. You very well pointed out that that population, which is not even as part of the productive economy, can participate in the economy and can be productive members. And as I said earlier, energy is on which humanity thrives and develops. So it is crucial. That is my take on it.
Mr. Shah, for your comments. I've actually had the opportunity to work on rural microgrids in Africa. We were for various areas where our own distribution company could not reach, and there were challenges. And I think one of the major challenges in a country like Pakistan, which is our attitude to cooperative collaboration. And that is one of the biggest challenges where, and you can see many in the past also, various funded programs back from 1970s and 80s. There have been attempts to create, enable various rural communities to generate biogas and operate a small power unit, etc. They've all not succeeded. So really what we need to study is, there are the technological aspects, there are the policy aspects, regulatory framework, but there's also, as Kotak Sahab mentioned, and I think Zafar Sahab also, there are the learning aspects and the evolution of people's thinking, how to make these microgrids happen successfully. So with this, one request would be, and that's a takeaway, that LUMS Energy Institute may consider this as being a standalone topic for one of its future discussions. Right. So with this, I'd like to go on to the next stage and throw the floor open for questions and answers. So let me first go to the online participants, because they are at a disadvantage, or maybe advantage in some manners. But let's open the forum for their questions first, and then I'll come to the people who are present here.
Hello, gentlemen. I'm Imran Hassan, Head of Training at DG Cement. We have here Mr. Noor Mohammed Somro. We have here Mr. Noor Mohammed. Hello, can you hear me?
Yes.
We have here Mr. Noor Mohammed Somro. He's Deputy General Manager and Head of the Power Plant here at DG Cement Plant and Hub. Over to you, Mr. Somro.
Sir, Assalamu alaikum. It was very nice and beautiful presentation by Mr. Masood Khan. We at here DG Khan Cement, we have a different type of source of generations. Right now we are getting 40 megawatt load from Karachi Electric. We also have a HO based power plant that's generating 24 megawatt. We have 30 megawatt coal-fired power plant. We have 10 megawatt waste heat recovery plant and also 1 megawatt solar power plant. My question for Mr. Masood Khan is this that during delivering his presentation, there was a slide 24/7 solar, in which typically we are getting solar generation almost 12 to 14 hours. But there is a bar in which the steam delivery is for 24 hours. My question is, how can I translate this steam while we are getting generation from solar that's 12 hours and the steam is for 24 hours. So this I want to clarification from Mr. Masood Khan.
If I understand your question correctly, it is your solar is 12 to 14 hours, and then you need steam for 24 hours.
Yes, exactly.
उसका तरीका ये है जी कि typically ना solar से you have a heating element which will create heat from the solar energy. उस heat को आप store करेंगे in some kind of a heat battery. उसके multiple materials हैं, carbon based. उस heat को when you store, it typically comes in a container of 10 megawatt hours each, and 20-foot container. A 40-foot container is about 20 megawatt hours, and then you can typically store that heat for as long as you want, but typical loss of heat is about 2% per day. So if you use it the same day, you will have a round trip efficiency for heat of about 97+%. Okay. So you can buy these storage containers which come with a heating converter element, and you connect it to your solar. So your solar is produced for 12 to 14 hours. You use whatever you want during the day, and for the rest of the hours, or even if you want to convert 100% into heat, then you can store it into heat, whatever you don't need, and use it at night for the balance of 10 hours. Have I answered your question?
Yes, okay, thank you, thank you.
और फिर उस heat container से आप steam create कर लें या hot water create कर लें. We can discuss with you separately. I can share my number वगैरह and we can discuss separately also.
That will be great.
Thank you. Thank you very much, Sumar Saab. Are there any other questions from DG Khan? Any other person? Before I invite the other people who are online. Oh. Okay. Is there any other question from any of the online participants? Okay. So let me come back first to the people present here. So the floor is open for yourselves to, please go ahead.
Masood sir, thank you very much for a great presentation. I'm Ajaz, and I'm just wondering about the solar potential of we have a great solar potential. Europe का जो solar potential है, it is 1200 kilowatt hour per meter square per year. 1200. हमारा बलूचिस्तान एरिया का 2200 किलोवाट आवर पर मीटर स्क्वायर पर ईयर है. जो पैनल की प्राइसेस हैं वो इंटरनेशनल मार्केट में वर्ल्ड रिकॉर्ड तोड़ रही हैं, इतना नीचे आ चुकी हुई है. जो पर वॉट प्राइस थी आज से 15 साल पहले $3.5 पर किलोवाट, वो अब ड्रॉप होके 9 सेंट पर वॉट पे आ चुकी हुई है. और पाकिस्तान का अभी रिसेंटली कंक्लूड हुआ है कि इलेक्ट्रिक ने सोलर पावर प्रोजेक्ट जो रिकॉर्ड लो है 4 सेंट के ऊपर वो प्रोजेक्ट अवार्ड हुआ है. तो हमारी जो इंडस्ट्री है वो बंद हो रही है. टेक्सटाइल इंडस्ट्री 9 सेंट के ऊपर मांगती रही है बिजली और वो सारी क्रैश कर गई है इंडस्ट्री. हमारा ये हब में बैठे हुए पूरा बलूचिस्तान जो है वो रड़ा मैदान खाली पड़ा हुआ है, मतलब समझ लें कि हाफ ऑफ द पाकिस्तान इज वो बैरन लैंड है, और हमारे बराबर में उधर जो है अफगानिस्तान है, और अफगानिस्तान जो है अपनी एनर्जी की रिक्वायरमेंट तकरीबन 78% ताजिकिस्तान से इंपोर्ट करता है। तो हम ये सोलर पावर प्रोजेक्ट को, माइक्रो ग्रिड्स को एम्प्लॉय करते हुए किस तरह हम एनर्जी सिक्योरिटी पाकिस्तान की भी इंश्योर कर सकते हैं एट दिस रॉक बॉटम प्राइस। वर्ल्ड लोएस्ट टैरिफ है इस वक्त, और पैनल की प्राइसेस इतनी लो मिल रही हैं। पाकिस्तान की भी कर सकते हैं किस तरह, और अफगानिस्तान की भी कैसे हम वी कैन विन देयर हार्ट्स एंड माइंड्स इंस्टेड ऑफ, इस वक्त हमने इतना उनको हॉस्टाइल कर दिया है अफगानिस्तान को, उनको हम चीप और अफोर्डेबल एनर्जी मतलब माइक्रो ग्रिड्स को एम्प्लॉय करते हुए उसकी ट्रांसमिशन एंड डिस्ट्रीब्यूशन कैसे होगी? दिस इज माय क्वेश्चन।
ये आज की प्रेजेंटेशन के रेफरेंस से ना मैं ऐसे एक पेपर देख रहा था सुबह, तो आई केम अक्रॉस अ नंबर कि 0.7% of land coverage of solar in Pakistan can fulfill 100% of its energy needs. So, adding to your comment, this is the potential. And वो पुरानी इकोनॉमिक्स की एक कहावत मुझे याद आती है, वो कहते हैं कि गरीब और अमीर में क्या, मुल्क में क्या फर्क होता है? कहते जी अमीर मुल्क दी हवाई चो बिजली बनती है, गरीब मुल्क दी हवाई चलती है। सो सेम चीज है जी कि ऑफ कोर्स इफ यू डू central planning, so all this is possible very quickly, but we've all seen the follies of central planning over the past, not any one government, but successively over the last 60 years. Pakistan की अगर आप हिस्ट्री उठाएं तो पाकिस्तान benefited hugely from the Indus Basin projects of the 50s and 60s. और वो equity आप literally आप देखें तो 2000s तक खाते रहे, of the Tarbelas and the Manglas and the barrages and all ये जो projects थे. अब yes, solar is another opportunity that can create a similar opportunity. Okay. But central planning पे डिपेंडेंट रहना तो बड़ा ही डिफिकल्ट काम है, इसलिए अपना अपना काम तो करें. सो आई थिंक प्राइवेट सेक्टर इज गोइंग टू डेवलप. सोलराइजेशन बड़ी तेजी से हो रही है, और यस यू आर एब्सोल्युटली राइट, जो टेक्नोलॉजी की कॉस्ट है वो बहुत रिड्यूस हो जाएगी है. और मुझे बड़ा दुख होता है, मैं आपको एक्चुअली बताऊं, जब मैं पढ़ता हूँ अखबार में, अभी भी पीछे इस्लामाबाद में एक जगह सेशन हो रहा था कि हमने सोलर पैनल मैन्युफैक्चरिंग में जाना है. मतलब ये हमारा लव अफेयर विद मैन्युफैक्चरिंग हैज टू गो अवे. हमारी जो मैन्युफैक्चर हम कर सकते हैं चीज, वो बंद हो रही है हाई कॉस्ट ऑफ एनर्जी की तरफ. हम फिर ऐसी चीजों में इन्वेस्ट कर दें जो कि हमारी टेक्नोलॉजी को फंसा देंगे और हम उसमें कभी डेवलप नहीं आगे हो सके, तो हमें क्या फायदा उसका? वी शुड यूटिलाइज द बेस्ट चीपेस्ट टेक्नोलॉजीज एंड अपनी एनर्जी कॉस्ट को हम कम करें. लाइक यू वेरी वेल पुट, अब दुनिया में 85-90% सोलर पैनल्स आर प्रोड्यूस्ड इन चाइना. क्या अमेरिका प्रोड्यूस नहीं कर सकता? कर सकता है, लेकिन वो नहीं करता क्योंकि उसे इतने सस्ते प्रोड्यूस होते हैं. उसको भी छोड़ें. वो एप्पल कंपनी तो अमेरिका की है, तो फोन तो चाइना में बनता है, तो पैसे तो अमेरिकनों के हैं ना, वो चाइना के तो नहीं है. उससे क्या फर्क पड़ता है मैन्युफैक्चर कहाँ होते हैं? आप रोज एग्जाम्पल देखते हैं कि आलू तो फार्मर को आता है, लेकिन पैसे तो लेज चिप्स वालों को मिलते हैं, वो भी अमेरिकन है. मकसद ये है कहने का कि आपको एप्लीकेशंस पे फोकस करना चाहिए, मार्केट्स पे फोकस करना चाहिए, ना कि बैक एंड टेक्नोलॉजी वर्टिकल इंटीग्रेशन पे, जिसमें हम अपने आप को फंसा देंगे उस ट्रैप में. सो आई थिंक प्राइवेट सेक्टर इज गोइंग टू इन्वेस्ट एंड इज कीप ऑन इन्वेस्टिंग, एंड आई थिंक एल्डेस जो लॉन्ग ड्यूरेशन स्टोरेज है, that is really going to put everything back further enable the private sector. और बहुत सा आप देखेंगे फ्यूचर में कि प्राइवेट सेक्टर ये इन्वेस्टमेंट्स करके और रिन्यूएबल्स का जो एक इंटरमिटेंसी का इशू है जिसकी वजह से ग्रिड पे बहुत ज्यादा डिपेंडेंस थी वो भी रिड्यूस हो जाएगा और मिटिगेट हो जाएगा एंड यू विल बी एबल टू डेवलप यू मे कॉल इट 24/7 सोलर बहुत से लोग इसको लॉन्ग ड्यूरेशन को कहते हैं 24/7 और पाकिस्तानी कॉन्टेक्स्ट में एक्चुअली लॉन्ग ड्यूरेशन एनर्जी स्टोरेज है ही 24/7 सोलर बिकॉज पाकिस्तान में सोलर इज मच मोर देन विंड सो रिन्यूएबल का मकसद ही पाकिस्तान में मेजॉरिटी केसेस में होता ही सोलर है ऑफ कोर्स बलूचिस्तान और सिंध और कोस्टल एरियाज कुछ है ऐसे या नॉर्थ में भी कुछ थोड़े से एरियाज हैं जहां पे विंड एनर्जी इज अवेलेबल बट प्राइमरीली पाकिस्तान में सोलर की इतनी अबंडेंस है कि you can couple it with some kind of a storage and you can have 24-hour energy and very very low cost. आपको पता है one of the biggest जो cost की आपने बात की बड़ी important है ये समझनी और अगर सुब्रो साहब सुन रहे हो तो ये बड़ी एक important information है कि अमेरिका में ड्राइव यहाँ से शुरू हुई 24/7 सोलर पे खास तौर पे कि थर्मल एनर्जी बहुत ही सस्ती है अमेरिका में गैस की प्राइसेस आर $3 पर मिलियन BTU जो पाकिस्तान में $14 है फॉर एग्जांपल उसको डीकार्बोनाइज करना ऑलमोस्ट इम्पॉसिबल था इकोनॉमिकली सो दीज थर्मल स्टोरेज एनर्जीज टेक्नोलॉजीज हैव बीन डेवलप्ड so that they are less than $3 of gas. Okay. So you will be able to decarbonize industry in America and Europe through thermal storage economically less than $3 equivalent to gas. हाँ पाकिस्तान का इकोनॉमिक ड्राइवर है पाकिस्तान में $14 की गैस है तो हमें तो इतनी सस्ती हीट भी नहीं मिलती तो वहां प्रैक्टिकली मुफ्त है so but we can use these technologies for our own benefit कि हम अपनी $14 की गैस जिससे हम थर्मल बनाते हैं उसको हम $3 वाली बिल के मुकाबले पे ले आए which practically converts into 4-1 रुपए की आजकल per unit of cost of the thermal energy so this is the potential and I think पाकिस्तान का जो प्राइवेट सेक्टर है वो बेइंतहा एंटरप्रेन्योरियल है और वो नॉट कि गवर्नमेंट सेक्टर नहीं है वो भी है जब वो होना चाहे बट मोस्ट ऑफ द टाइम प्राइवेट सेक्टर इट्स वेरी एंटरप्रेन्योरियल एंड आई थिंक दे विल इन्वेस्ट इन दीज टेक्नोलॉजीज एंड बिकम सस्टेनेबल बल्कि इन रूरल एरियाज में आई थिंक there will be opportunity because of such low cost कि ये अपनी local communities और जो micro grids rural आप कह रहे हैं उनको भी ये industries और private sector serve कर सकेगा because typically एक बड़ी जगह एक बहुत सी जगह पे दुनिया में इसका एक बड़ा अच्छा मर्जर हो जाता है कि जिस तरह सीमेंट प्लांट्स हैं उनके इर्द गिर्द जो कम्युनिटीज हैं जो रहती हैं जो टिपिकली लैंड ओनर्स भी होते हैं या उनके को राइट्स होते हैं उन लैंड्स पे तो वो उनकी इम्प्रूवमेंट के लिए कम्युनिटी इम्प्रूवमेंट के लिए बहुत सी वैसे भी एफर्ट कर रहे होते हैं सीमेंट फैक्ट्री वाले फर्टिलाइजर कंपनियों वाले तो दे कैन इवन सप्लाई दीज renewable energies at such low cost for the benefit of those communities and they can create their own microgrids for the benefit at very low cost.
वो पार्ट रह गया सर अफगानिस्तान कैसे ट्रांसमिशन डिस्ट्रीब्यूशन कैसे होगी
सर मैं उस पर कमेंट इसलिए नहीं कर सकता कि मेरे तो बाप दादा खुद वहां से भाग आए थे
Any other panel members like to add?
आपका क्वेश्चन क्या है
सर अगर हम बलूचिस्तान में जनरेट करते हैं सोलर पावर प्लांट मेगा स्केल के लगा देते हैं तो हम अफगानिस्तान को माइक्रो ग्रिड्स एम्प्लॉय करते हुए कैसे उसकी ट्रांसमिशन डिस्ट्रीब्यूशन कर सकते हैं? कोई एनर्जी कॉरिडोर बनाया जा सकता है?
जिस तरह इस वक्त आपने जो ताइपी का सुना होगा, ऑलरेडी वो एक फोरम मौजूद है जिसपे काम चल रहा है, तो दिस इज पॉसिबल कि इसके अलावा तो कोई सोल्यूशन नहीं है ना। जब वहां पे जनरेशन सोलर की हो सकती है तो फिर हो सकता है कि हम पाकिस्तान को भी वो सी के थ्रू कॉरिडोर थ्रू एक्सपोर्ट करें। तो ताइपी के चल रही है बातें, जैसे फाइनल हो जाता है तो ये भी अपनी हो जाती है, क्योंकि आजकल चाइना भी अफगानिस्तान में पहुंच चुका है, काफी वहाँ डेवलपमेंट हो रही है। तो हो सकता है कि सोलर पावर वहां पे जनरेशन शुरू करे और इसी कॉरिडोर के थ्रू आगे दे दे।
इस पर मैं एक चीज सिर्फ ऐड करना चाहूंगा, मतलब मैं थोड़ा सा इन्वॉल्व रहा एक इनिशिएटिव का जो चाइना स्टेट ग्रिड का था, और जिस कंपनी ने ये लाहौर में तैयारी HVDC लाइन लगाई है, ये जो ये उनके थ्रू एक्चुअली, और ये चाइना स्टेट ग्रिड की कंपनी है। अंडर द वन बेल्ट वन रोड इनिशिएटिव, चाइना का एक प्लान ये था, वो अभी भी है, थोड़ा डिले हो गया, लेकिन मे बी इन फ्यूचर इट विल बी इम्प्लीमेंटेड, कि नॉट ओनली उन्होंने ट्रेन लिंक्स बनाने, बट उन्होंने सारी चाइना, पाकिस्तान, अफगानिस्तान, इंडिया और ईरान, ये सारी ग्रिड्स भी कनेक्ट करनी है। जिस तरह अगर आप देखें तो यूरोप में सारी यूनिफाइड ग्रिड्स हैं, और हर मुल्क की ग्रिड इज कनेक्टेड टू द अदर ग्रिड। पहले ये बड़ा कॉम्प्लेक्स सिस्टम क्रिएट हो जाता था, बट जब से HVDC हैज बिकम easily, relatively easily available, so you can run grids connected asynchronously. तो एक ग्रिड का फॉल्ट दूसरी फॉल्ट ग्रिड पे जाएगा ही नहीं। So HVDC lines की वजह से, but this is a subject I think that will possibly happen maybe in the decades to come, और हमारे बच्चे इसको देखें। But अगर वो शुरू करें, लाइक वो चाइना में कहते हैं ना, वो 1,000-mile journey starts with one step, so maybe Pakistan can have a connected grid to Afghanistan.
Thank you very much. Is there any other question? आप कर ले, उसके बाद आपके पास आ जाते हैं। How are we for time?
Close our time.
Okay.
We can do
Question ले ले।
5 minutes.
Sir, my name is Amal Naseem. I'm running a solar energy company, EPC company. So, sir, my question is that in Pakistan we are going rapidly towards solarization, and currently अगर देखा जाए, so right now from January till date, अगर इस साल की imports का data भी निकाला जाए तो 10 gigawatt solar import हो चुका है पाकिस्तान में। Considering the fact, और इससे पुराना भी data भी देखें तो 80% solarization के दौरान चलेगी। अब सर हमारे पास यहाँ पे इश्यूज क्या आ रहे हैं कि हमारे पास कुछ एनर्जी की फिक्स्ड कॉस्ट हैं, फॉर एग्जांपल इन टर्म्स ऑफ IPPs, और जो है ना वो हमें देनी है एज अ कंट्री। तो डू यू थिंक द मॉडल ऑफ गोइंग टुवर्ड्स सोलराइजेशन इज सस्टेनेबल? बिकॉज इफ पाकिस्तान गोज टू 40 या 50% टुवर्ड्स सोलराइजेशन, तो हम क्या सस्टेन कर पाएंगे पाकिस्तान एज अ कंट्री इस मॉडल को, IPPs को साथ लेके चलते हुए? एंड जिस तरह बात सेकंड इसमें जो है ना, मेरा सवाल इसमें है कि जो हमारी एनर्जी स्टोरेज डिवाइसेस हैं इस टाइम, इफ वी डोंट हैव दैट इन लाइन, तो जो है मतलब कि इस मॉडल को सस्टेनेबिलिटी मेरा नहीं ख्याल अचीव हम कर सकते। आई वुड लाइक टू हैव योर कमेंट ऑन दिस।
देखिए, अगर आप ना लीनियरली सोचें, लीनियर थिंकिंग होती है कि आपने ये किया और ये रिजल्ट निकला, तो सही कह रहे हैं आप। लेकिन हिस्ट्री हमें ये बताती है कि हर प्रॉब्लम के कोई नए सोल्यूशन, हर सोल्यूशन के नए प्रॉब्लम क्रिएट होते हैं, और हर प्रॉब्लम से कोई नए सोल्यूशन क्रिएट होते हैं। ठीक है। एंड जब नई चीजें क्रिएट हो रही होती है ना, तो नोबडी कैन प्रिडिक्ट कि आगे क्या होगा। मसलन उसका सबसे क्लासिकल एग्जांपल ये दिया जाता है कि शॉपिंग मॉल्स दुनिया में इसलिए बनी सुबर्ब्स में कि लोगों के, और सुबर्ब्स बने कि लोगों के पास गाड़ियां आ गई थी और लोग शहर से बाहर जा सकते। तो जिसने गाड़ी इन्वेंट की वो कभी सोच भी नहीं सकता था कि गाड़ी की वजह से शॉपिंग मॉल या सुबर्ब्स बनेंगे। सो सेम चीज द टेक्नोलॉजी में अप्लाई होती है। आई डोंट हैव अ फ्रैंकली डायरेक्ट आंसर टू दिस। ऑन द फेस ऑफ इट ऐसा ही लगता है कि ये सस्टेनेबल मॉडल नहीं है। But then there are so many competing technologies and so many other things happening in the world. Okay, और पॉलिटिक्स, और उस पॉलिटिक्स के साथ मतलब 9/11 हुआ तो दुनिया बदल गई। So there are all these huge events that happen in the world all the time. COVID आया तो कुछ और कहानी होगी, you know. So these are the things that will happen. So one should be optimistic and have faith, and let's see how it grows.
थोड़ा सा मैं इसमें आपको बताना चाहूंगा कि ये बिल्कुल विजिबल मॉडल है और फ्यूचर के लिए बड़ा अच्छा है। हमारी कंट्री की जो एनर्जी की जनरेशन है वो मतलब 10-20 साल पहले, 20-30 साल पहले हाइडल की ज्यादा थी, थर्मल की कम थी। उसके बाद जो रेशियो हमारा हो गया था वो थर्मल की ज्यादा हो गई, हाइडल की कम हो गई, रिन्यूएबल कम हो गई। उसके बाद प्राइवेट सेक्टर ने भी और गवर्नमेंट सेक्टर ने भी इनिशिएटिव लिया और रिन्यूएबल की तरफ जा रहे हैं। ये एक अच्छी बात है और आगे भी जाना है जब तक ये एनर्जी मिक्स हमारा बैलेंस ना हो जाए। जहां तक बात है कि दिन ब दिन चूंकि टेक्नोलॉजी इंप्रूव हो रही है, सोलर जैसा आपने बताया कि पैनल बड़े सस्ते हो रहे हैं, ये बड़ा आम हो रहा है। लेकिन थोड़ा सा बीच में ये जो आ गया था नेट मीटिंग की इशू की वजह से थोड़ा सा सिलसिला रुका था। अदरवाइज इसको छोड़ के अगर जिस तरह इंडस्ट्री की सोलर सिस्टम लगाती है तो उसको बड़ा फायदा है, कम से कम अपनी जनरेशन तो वो करेगी ना। और अगर थर्मल एनर्जी पे जाते हैं, मैं चूंकि थर्मल से मेरा वास्ता भी रहा, लेकिन चूंकि थर्मल एनर्जी के लिए फ्यूल फिर भी सवाए थर्मल के जितने भी फ्यूल्स हैं बाकी इंपोर्टेड, हमें वहां को पैसे देने पड़ेंगे। जबकि हम अगर सोलर पे जाते हैं या विंड पे जाते हैं तो हमें पैसे देने नहीं पड़ेंगे, खाली जो इनिशियली प्रोजेक्ट की कॉस्ट होती है जिसमें फार्म के कंपोनेंट जो आते हैं वो आएंगे, उसके बाद तो फ्यूल की कोई कॉस्ट नहीं है। तो इसमें डिसहार्ट होने की जरूरत नहीं है, ये बड़ा अच्छा है और फिजिबल मॉडल है। और हमें कोशिश करनी चाहिए कि इसको जरा बड़े पैमाने पे, इवन अभी हुकूमत भी ये गवर्नमेंट भी सोच रही है कि सोलर पावर प्लांट्स लगाएं। जिस तरह मुजफ्फरगढ़ के लिए प्रोजेक्ट जो आया था सोलर पावर प्लांट का, लेकिन उस वक्त इन्वेस्टर कोई नहीं आया। अब चूंकि टेक्नोलॉजी सस्ती हो गई है और दूसरा इन्वेस्टर को थोड़ा सा ट्रस्ट चाहिए कि मैं जो इन्वेस्ट कर रहा हूँ मुझे रिटर्न कैसे मिलेगा, किस तरह मिलेगा, वो थोड़ी सी क्लियरिटी है। अभी इस वक्त जो इनिशिएटिव हो रहे हैं जिसके लिए गवर्नमेंट चाह रही है कि फॉरेन से मतलब पैसे बाहर से आए, इन्वेस्टर आए, तो इस पे काम हो रहा है। हो सकता है जल्दी इसका सोल्यूशन भी निकल जाए और ये अच्छा इसका फीचर है सोलर पावर प्लांट्स का।
मैं थोड़ा सा डिफरेंट पर्सपेक्टिव दे देता हूँ इसमें। सोलर की जनरेशन, सोलर पैनल्स अकेले पे डिपेंडेंट नहीं है। अगर आपका सोलर ग्रिड कनेक्टेड है सो इट रिक्वायर्स अ स्टेबल ग्रिड, जिसका मतलब है कि आपको कहीं ना कहीं पे कैपेसिटी की पेमेंट्स किसी और मद में देनी पड़ती हैं। अभी आजकल जो हमारे मोड ऑफ एंगेजमेंट है उनके अंदर हम उन कॉस्ट को देखते नहीं है, हम एज्यूम कर लेते हैं कि वो है। अगर आपने सोलर की वायबिलिटी देखनी है, एंड अगेन एलईआई में जो स्टडीज हुई हैं विद बैटरी स्टोरेज सोलर जो कि सेल्फ कंटेन सेल्फ सस्टेनेबल है, उनकी प्राइसेस भी इस वक्त की ग्रिड इलेक्ट्रिसिटी की प्राइसेस से कम है, विच बेसिकली मीन्स कि हाँ उसके अंदर एक सस्टेनेबल फ्यूचर है of increasing, but not in the current way in which we perceive how solar is going to be utilized. So we need to look at solar and storage together and still create a viable future, renewable based and storage के साथ integrated with the current state of technology, which hopefully is going to improve over time. जो trend जा रहा है.
Thank you. So we'll take the last question. Quick one, please, and quick responses because we are coming to 5:45.
Thank you very much, Mr. Sir, for your valuable time. मेरा सर आपने कहा कि हमें मैन्युफैक्चरिंग की तरफ नहीं जाना चाहिए या उस तरफ बात नहीं करनी चाहिए, हमें एप्लीकेशंस की तरफ जाना चाहिए। लम्स इंस्टीट्यूट एक स्टडी कर रहा है और गवर्नमेंट उसको बड़ा स्ट्रिक्टली परस्यू कर रही है पावर सेक्टर इंडिजिनाइजेशन प्लान के ऊपर। तो आपको नहीं लगता कि जो इलेक्ट्रिकल पावर सेक्टर में जो इलेक्ट्रिकल पावर इक्विपमेंट है, सोलर इज वन ऑफ देम, बैटरी स्टोरेज है, ग्रिड के इक्विपमेंट है, यहाँ पे मीटर बना रहे हैं, ट्रांसफार्मर बना रहे हैं, स्विच गियर्स बना रहे हैं, तो हमें लो हैंगिंग फ्रूट्स पे फोकस करके लोकल इंडिजिनाइजेशन पे फोकस करना चाहिए, या हम बस 95% जैसे कि हमारी इंपोर्ट्स, हम इंपोर्ट्स पे रिलाई करते हैं।
Okay, before Mr. Saab, I invite you to respond to this. In our consulting, because we do consulting for private sector as well as now we are doing it for the government and assisting them in the policy making for investment promotion, etc. It takes us to a lot of different sectors, right? So वो मैं आपसे पहले शेयर करूँ और मैन्युफैक्चरिंग का पॉइंट। See, some buses have already left the station. So जब हम बात करते हैं सोलर पैनल बना लेते हैं, जरूर बनाएं वो, लेकिन ये कि you'll never be competitive with those people जो कि आज से 20 साल पहले जिन्होंने काम शुरू किया था और उन्होंने उसकी वॉल्यूम्स और स्केल्स ऑफ इकोनॉमी पे अचीव कर ली है, टेक्नोलॉजी मूव कर लिया। There are always buses that are available now for you. So in every sector, including this one, the energy sector, if you start making steam turbines today, right? मैं एक मिसाल दे रहा हूँ, low hanging fruit भी ट्रांसफॉर्मर्स बनाने शुरू कर दें। बहुत सारे ऐसे एरियाज हैं where we need to see कि हमने बस कौन सी पकड़नी है, right? And therefore इस वक्त वो आइडेंटिफाई करना बहुत जरूरी है। तो आई डोंट थिंक मसूर साहब का जो रिस्पॉन्स था वो उस कॉन्टेक्स्ट में था कि हमें मैन्युफैक्चरिंग करनी नहीं चाहिए। वन ऑफ द मेजर थिंग इज कि आपकी एनर्जी कॉस्ट इतनी हाई है कि जब आप किसी भी मैन्युफैक्चरिंग में जाएंगे, एंड दिस इज व्हाट वी एज बिजनेस कंसल्टेंट्स आल्सो फाइंड आउट कि यार वो कॉस्ट स्ट्रक्चर ही आपका ऐसा है कि इट्स डजंट मेक द मैन्युफैक्चरिंग कंपेटिटिव। तो अनकम्पिटिटिव चीज बनाने का उस तरह से फायदा नहीं है। अगर आप कहते हैं कि यार वो हम इंडिया पॉलिसी चले जाएं जो उन्होंने सोशलिस्ट बेस्ड पॉलिसीज की थी बैक इन द 50s के यार बाहर से किसी को नहीं आने देना, उसके नताइज भी हैं। उसके नताइज ये हैं कि यू एंड अप मेकिंग थिंग्स दैट द कंज्यूमर डजंट वांट, यू ट्राइंग टू सेल थिंग्स दैट आर outdated or whatever or uncompetitive when you are actually subsidizing the local manufacturers. दूसरी चीज ये है कि another point was कि in every sector we find कि the opportunity is पाकिस्तान की natural resources हैं। सोलर की बात कर रहे हैं। By the way, I'll share an anecdote with you regarding this Balochistan thing, but not here, but over the cup of tea. कि वो क्यों नहीं हुआ, why are we failing there? So वो हर सेक्टर के अंदर हमारे यहाँ there are structural anomalies or defects. सिर्फ अगर वो हम as a policy base हम उनको debottleneck करते हैं, then you will be able to harness your resources properly. मजरूर साहब कह रहे थे ना कि जहाँ लोग दौलतमंद हैं उनके हवा से बिजली बन रही होती है और गरीब लोग हैं उनके हवा चल रही होती है। That's really a story of ability of not harnessing, sorry, inability of harnessing your resources properly. और एक हमारा जो conundrum है जो हम solve नहीं कर सके as a country, वो ये कि we have a great competence और वो competence ये है is our inability to make things work. ये हमारी बहुत कॉम्पिटेंस है कि हम कोई भी चीज हमें दे दें तो हर चीज पड़ी होगी, बिल्डिंग ब्लॉक्स मौजूद हैं एंड कॉमन सेंस से नजर आ रहा है कि यार वी जस्ट हैव टू पुट दीस टुगेदर एंड we'll have brilliant results, but we are unable to put those building blocks together. So with this, let me go back to Masroor Sahab.
आसिफ मैडम, इसका मैं आपको ये सब्जेक्ट ऐसा है, आई फील वेरी स्ट्रांगली। मैं आपको इसके एग्जांपल्स पॉजिटिव और नेगेटिव दोनों देता हूँ। कोई मैन्युफैक्चरिंग को चलाने के लिए ना एक इकोसिस्टम क्रिएट चाहिए होता है। कोई आइसोलेशन में आज की दुनिया में नहीं चल रहा। और वो इकोसिस्टम के लिए मल्टीपल सप्लाई चेन सोर्सेज सप्लायर्स हैं और कस्टमर्स हैं और इनेबलिंग एनवायरनमेंट्स। अगर वो एग्जिस्ट ना करती हो और आप किसी गवर्नमेंट पॉलिसी या कस्टम ड्यूटी लगा के और उसको आर्टिफिशियली इम्बेड करेंगे ऐसे चीज को, तो वो कभी भी हाईली प्रोडक्टिव नहीं होता, हाईली एफिशिएंट नहीं होता और आप रेस हार जाएंगे डे वन से। इसके मैं आपको ना थोड़े से सिंपल बड़े प्रैक्टिकल एग्जांपल देता हूँ। क्या आप आम का पौधा मरी में लगाएंगे? नो, वो नहीं बनेगा, चलेगा, शायद लग भी जाए कोई आम 100 लगाओगे 2 चल जाएगा, वो भी मीठा नहीं होगा। और आपको पता है रेबिया खान चलाओगे तो 100 से 90 चलेंगे और मीठे भी होंगे तो बड़े भी होंगे और वो 500 रुपए किलो बिके। क्यों? उसकी इन्वायरमेंट है ना, उसका टेम्परेचर है, उसका वेदर है। आप उसका ग्रीन हाउस क्रिएट करके उसको मरी में लगा दें तो कॉस्ट डबल हो जाएगी ना आपकी। उसी कॉस्ट में तो नहीं मिलेगा जो नेचुरल एनवायरमेंट में मिलता है। अब मैं इसको आपको दूसरा एग्जांपल दे दूं। आप सियालकोट चले जाए, फुटबॉल में फुटबॉल बन रहा है। उन्होंने एक हिस्टोरिकली जिस वक्त एक टाइम था उन्होंने इधर इकोसिस्टम बना लिया, दुनिया में उनसे कोई कम्पीट नहीं कर सकता। अब तो सिंथेटिक फुटबॉल आ गया, वो उसमें भी उन्होंने डेवलप कर लिया। उन्होंने एक इकोसिस्टम पहले ही क्रिएट कर दिया, पिंड पिंड घर घर औरतें बैठी हैं और कोई फुटबॉल सीख रही है, कोई ब्लैडर बना रही है, कोई कुछ कर रही है, कुछ कर रही है। उन्होंने मार्केट कैप्चर कर ली। अब दुनिया में उनसे कोई कम्पीट नहीं कर सकता। क्या सोलर स्टेज पे है पहले दुनिया में? नो, इट इज अ मैच्योर इंडस्ट्री वेयर टेक्नोलॉजी हैज मैच्योर। चाइना आप देखो, आप अपने शहरों में देख लें पुराने के चमड़े का एक बाजार है, सारे शहर में नहीं फैला हुआ चमड़ा, उसका एक इकोसिस्टम है वो, उस बाजार को जो सपोर्ट करता है। ठीक है, आप जाते हैं तो कपड़ों का एक और बाजार है। आपने अगर कपड़ा खरीदना है तो आप शालमी नहीं चले जाएंगे, आप वो दूसरे वो जो मार्केट है शालमी के साथ, आजम मार्केट, आप उधर जाएंगे तो आपको जगह जगह 5000 दुकानें हैं, ऐसे ट्रेडिंग होती है, हर किस्म का कपड़ा उसी जगह पे लीस्ट कॉस्ट पे आपको मिल जाएगा। तो जब आप आर्टिफिशियली कोई चीज ग्रो कराएंगे अपने यहाँ, चाहे वो मैन्युफैक्चरिंग हो, चाहे वो प्लांट हो या कोई भी चीज हो, तो वो कभी पनपेगा ही नहीं। ना आप टेक्नोलॉजी में उनसे compete कर सकेंगे, ना आप कॉस्ट में उनसे compete कर सकेंगे, और आप कोई रेगुलेटरी ड्यूटियां लगा के ना अपने पूरे मुल्क और कंज्यूमर को फंसा लेंगे। ऐसा काम क्यों आप करना चाहते? जिसकी वजह से फिर ये होता है कि यार देखो 1 करोड़ रुपए की होंडा सिविक मिल रही है, सीटें भी सही नहीं है, बाहर की गाड़ी के मुकाबले में मैन्युफैक्चरिंग भी सही नहीं है, क्योंकि आपने कार की लोकलाइज भी करना है, डिलीशन भी करनी है, वॉल्यूम है 40,000, उस पर कभी जस्टिफाई नहीं हो सकती कोई चीज। तो सारे साइकिल में आप फंस जाते,
जीवी कर सकते हैं, जीवी
फायदा ही कोई नहीं है जी। आपको क्यों करें? आप एप्लीकेशन पे फोकस करें।
आई थिंक इसके अंदर ना मल्टीपल व्यू पॉइंट्स हैं, उसको
ये
एक छोटा सा आपने जो है ना वो अपॉर्चुनिटी देखी है।
आई एम ओनली टॉकिंग अबाउट माय पॉइंट ऑफ व्यू।
देखिए उस वक्त ना शहीद भाई से, शहीद भाई ना मेरी बड़ी उम्र है, अभी मैं रिटायरमेंट के बिल्कुल करीब ही हूँ। Said Bhai was a local household name for decades as the indigenous meter manufacturing के अंदर बहुत बड़ा नाम था। जिस वक्त सईद भाई ने मीटर लोकल मैन्युफैक्चरिंग बंद की थी, वो पाकिस्तान के लिए दुख का दिन था। उनको वो रियलिटीज जो वो बता रहे हैं उसके पीछे एक हिस्ट्री है पूरी। एट द सेम टाइम सिर्फ ट्रेडिंग वाला माइंडसेट एक कंट्री के अंदर 5th लार्जेस्ट पॉपुलेशन के अंदर इट हैज इट्स ओन सेट ऑफ प्रॉब्लम्स। चिकन एंड एग सिचुएशन है। We need to break this chain and we need to find opportunities, find the right bus, find the right buses at this point in time. This is not a quest that we can leave, but again हम उसको blindly,
I agree with that.
मरी में हम
solar
काम कर
panel is
रहे
not
हैं,
that.
100% agree because of multiple reasons.
There are others.
But solar panel को commodity के तौर पे treat करते हुए उसके ऊपर value additions and then creating that value before anybody else, before even China does, for other developing countries, including Afghanistan, which is right there. जिसके अंदर बहुत बड़ा potential है to grow. I mean, we need to look at those opportunities and then see how we can evolve this ecosystem. We can't let the ball drop. That's the primary thing.
हमें ये देखना चाहिए कि हमारा इकोसिस्टम का, मसलन मैं एक एग्जांपल देता हूँ आपको, सिलिकॉन वैली अमेरिका में भी एक ही है, क्यों? छोटे छोटे हैं दूसरे, हालांकि नॉलेज सेंटर अमेरिका का बॉस्टन और नॉर्थ ईस्ट है, सिलिकॉन वैली वेस्ट में है, फाइनेंशियल सेंटर न्यूयॉर्क है, वो भी नॉर्थ ईस्ट है, जो दोनों सबसे बड़े एनेबलर हैं टेक्नोलॉजी के। लेकिन उबर एक सॉफ्टवेयर है जो सिलिकॉन वैली से निकला, क्यों? पैसे भी न्यूयॉर्क से आते हैं, नो हाउ भी नॉर्थ ईस्ट से आता है, क्योंकि वहां एक इकोसिस्टम है। वो कहते हैं उधर पूरा एक क्रिएट हुआ हुआ है सिस्टम, एनवायरनमेंट। ऐसे बंदे हैं जो कहते हैं ला दो 100 प्रोजेक्ट्स पे 1000 रुपया ला दें, 90 फेल हो जाते हैं, 99 फेल हो जाते हैं, एक जो सक्सेसफुल होता है वो कहते हैं ठीक है, वो किसी को इंक्वायरी नहीं करते कि तू फेल क्यों हुआ। पूरा एक सिस्टम एग्जिस्ट करता है ना वहाँ। अब सिलिकॉन वैली जो है वो फ्रांस में क्यों नहीं? तो दिस इज, हमें वो काम करने चाहिए जो हमारी एनवायरनमेंट।
One quick remark on this point, Kotak Saab, and then I'll go to Zafar Saab to.
One question.
मैन्युफैक्चरिंग का, हाँ, हमें ज़्यादा अपने इंडिजिनियस रिसोर्स को इस्तेमाल करना चाहिए। जो इंडस्ट्री अगर हम आज लगाएंगे तब जाके इम्प्रूव होके होगी, लेकिन जिस तरह सूर्य खान साहब ने कहा कि कॉस्ट को भी देखना है, उसकी कॉस्ट क्या पड़ेगी, लेने वाला कोई नहीं, को कम्पीट नहीं कर पाएंगे। हाँ, कुछ ऐसी इंडस्ट्रीज हैं जो लोकल होनी चाहिए, जिस तरह से व्हीकल की इंडस्ट्री है, यहाँ पे पार्ट्स बनने चाहिए। इस तरह की कई और इंडस्ट्रीज हैं, लोकल होनी चाहिए, हो भी रही है। गुजरात में देखें लोकल इंडस्ट्री कितनी है, वो चल भी रही है, और ये आस्ता से इम्प्रूव होती जाएगी, क्वालिटी बेहतर होती जाएगी, फिर कम्पीट कर सकते हैं। लेकिन जहां तक सोलर की बात है, सोलर पैनल की इस वक्त मैन्युफैक्चरिंग करना हाँ हो सकती है, शुरू की जा सकती है, लेकिन शायद कम्पीट ना कर पाए हम। हाँ, अपनी मुल्क की जरूरत शायद पूरी कर सकते हैं अगर वो प्राइस में कम्पीट कर पाए तो बहरहाल ओवरऑल आज की डिस्कशन बड़ी अच्छी रही एंड बड़ी फ्रूटफुल है सबके लिए। इस तरह के इवेंट्स फिर होते रहेंगे इंशाल्लाह। Over to.
Excuse me, sir. Can we take the liberty to ask one last question, last but not the least, from
Yeah.
DG? Our head of electrical division and assistant general manager electrical, Mr. Mustafa Pasha, would like to ask a question. Mr. Mustafa Pasha.
First of all, thank you very much, Mr. Masroor and LUMS for arranging such an informative session on microgrids. Sir, I would request that please arrange another session on the same topic, including me. There are a lot of questions which cannot be asked in such a short session. जितनी ऑडियंस बैठी हुई है इनके सबके जहन में बहुत ज़्यादा क्वेश्चंस हैं, तो मैं ये रिक्वेस्ट करूँगा कि एक और सेशन किया जाए। सेकंड सर ये है कि वो ताइपी का जो प्रोजेक्ट है उस पर एक अपडेट मैं लिबर्टी लूँगा कि यहाँ अपडेट कर दूँ। ताइपी प्रोजेक्ट में पाकिस्तान में नौशेरा में कन्वर्टर स्टेशन लग रहा है, जिसमें 500 kV के जो ट्रांसफार्मर्स हैं उनकी जो कमीशनिंग है वो हो चुकी है। तुर्कमानिस्तान में जो ट्रांसमिशन लाइन है या उन्होंने जो सिस्टम लगाना है वो लग चुका है। अफगानिस्तान में जो है वो मटेरियल पहुंच चुका है जो ट्रांसमिशन लाइन का। तो ये इसके ऊपर एक छोटी सी अपडेट थी। लास्ट वीक में क्या इंजीनियर हैं जो उस पर काम कर रहे थे, उनसे वो उन्होंने विजिट किया था, तो मैंने कहा मैं भी ये इंफॉर्मेशन आप लोगों से शेयर करूँ।
Thank you.
Thank you very much.
Thank you very much. I think there are some more requests for questions, but मेरा ख्याल है टाइम अब 6 बज गए। This जो DG Consummate से है कि to have another session, वो I'll request LUMS Power Center to actually consider. There have been such precedents in the past also. सो वो आप देख लीजिएगा और जिनके क्वेश्चंस हैं वो इन राइटिंग भी अगर भिजवा देंगे बाद में तो मैं रिक्वेस्ट करूंगा कि उनकी रिस्पॉन्सेस चली जाएं। थैंक यू वेरी मच। नुमान सर प्लीज जस्ट योर लास्ट क्लोजिंग रिमार्क।
जी बहुत बहुत शुक्रिया अगेन from Lungs Energy Institute. I thank all the panelists, Masood Saab for the talk as well, and all the people who participated in this seminar. Again, it's wonderful. Lungs Energy Institute का एक ही mandate है, and that's to work in the domain of energy and power, and specifically power systems के जो challenges हैं, उनकी identification and then subsequent solutions की side पे, पॉलिसी रेगुलेशन की साइड पे, नए डिजाइन की साइड के ऊपर कोई ना कोई एफर्ट करते रहना है. सो अगेन दिस इज वन ऑफ द कोर क्रूशियल एरियाज where I think in the years to come we will probably be moving more or very important topic, and I agree कि इस पे और ज्यादा discussions की जरूरत है और हमें इसको continue करते रहना चाहिए. बहुत बहुत शुक्रिया.
Thank you very much. And with this, we close the session. Thank you very much. I must say a few words of appreciation for the organizers. अरेज हैं और उनके पीछे काफी मेहनत करने वाले यंग लोग और ओल्डर लोग भी होंगे, बट यंग लोग मुझे नजर आ रहे हैं. Thank you very much.
Young at heart.
Young at heart. Thank you. Thank you very much. And keep it up.